Welcome to video 5.2, Sampling Distributions for One Population. Okay, so when we're talking about sampling distributions for one population, sampling distributions for populations are on our formula sheet. So we have for proportions, and it gives us a whole bunch for one population. So this is the information I'm looking for mean and standard deviation, or for means for one population is right here. Okay, we even labeled them the sampling distribution for X bar, and this is the sampling distribution for P hat. Okay, so that's where they are on our formula sheets. What we'll be looking for is if we have a parameter, we're going to start with the proportion here. Remember, your parameter is noted with P, and that represents your population proportion. Your statistic here will be P hat, and that is going to be your sample proportion. Now, we'll know if our shape is normal or not, so we're going to say normal if. For proportions, you have to check n times p and n times 1 minus p. And both of those numbers need to be greater than or equal to 10, and you have to be sure to make the comparison to 10 for this to work for full credit. Now, from our formula sheet, if we're talking about a sample proportion for one sample, we just look, here's our mean and here's our standard deviation. So this is our center and our variability. Okay, so our center for the sampling distribution of P hat will be whatever our P is. And our variability, our standard deviation for our sampling distribution of P hat will be P times 1 minus P divided by N. So I just got those formulas off the formula sheet. Now to find the z-score for a proportion. So our z-score will be our P hat minus our P divided by our standard deviation. Okay, so let's take that and let's work an example with this information. So at a large local high school, 52% of the previous year's graduating class enrolled in a four-year university the following fall. The school counselors contact an SRS of 50 students from the previous year's graduates. Find the probability that an SRS contains at least 23 students who are enrolled in the four-year university. So the word at least, that's going to be greater than or equal to. That should help us with our drawing when we do this. So what information are we starting with here? So all of last year's graduating class, 52% were going to a four-year university. That's our parameter. So our P equals 0.52. That's what it was at the end of last year, all of them. Now, from all of those people who graduated last year, the counselors contacted 50 of them. And we're curious about at least 23 who are enrolled in a four-year university. So our P hat here, remember we don't want naked numbers. So I'm going to show where I'm going to get the number. I'm going to say the 23 out of 50 would give us a P hat of 0.46. So I've got a number to work with there. Now let's check our shape so we know kind of what we're dealing with here. So it's normal if n times p is greater than 10. So this is n times p, not n times p hat, n times p. If you have p, you have to use it. So we have 50 times 0.52, which is 26. And then n times 1 minus p, so 50 times 0.48 gives me 24. So both of those numbers are greater than or equal to 10. So we are approximately normal. Okay, I'm going to keep going. The center should be the same as the population according to this, the center of our sampling distribution. So our mean of our sampling distribution should be the same as the mean of the population of 0.52. Then for our variability, we would plug everything in. So we would have 0.52 times 0.48 divided by 50. And you would get, once you calculate that out, 0.071. All right, so I'm going to save the z-score and do the work down below where I have a little bit more room for it. But now we have a whole bunch of important information that we can work with here. So for our picture, we already determined it's normal. So I'm going to draw a normal curve. And the way we show it's a normal curve is we're going to say n for normal. And it has a mean of 0.52 and a standard deviation of 0.071. Okay, this will give us full credit that we're indicating it's a normal distribution and we defined our parameters of mean and standard deviation. So 0.42 will go in the middle. And we're curious about at least 23 out of the 50 who are still enrolled in college. Well, the 23 out of the 50 gave us the 0.46. So in this normal curve, 0.46 will be to the left. But I want to know at least, so I am actually looking for this shaded region. All right, so that's what we're looking for. We drew our normal curve, so that should help us with our answer too. But it also helps us establish a whole bunch of important information that's required in an FRQ. So to show our work, we got our z-score. We're going to take our statistic minus our parameter and divide it by our standard deviation. And when I calculated it out, I got negative 0.85 for my z-score. So that's 0.85 standard deviations below the mean, which we can see. Here's the mean, so it is below the mean, so we're good there. When I look up the area for that on table A, I got an area of 0.1977, but I shaded greater than, so I need to do 1 minus that number to get a final answer area of 0.8023. So there's an 80% chance that at least 23 out of the 50 students will still be enrolled in a four-year university. Now, that's for proportions. Now we're also going to do a one sample mean problem. It's the same kind of process, but where the information comes from looks a little bit different. Now, how do you know the difference if we're asking about proportions or for means? Well, here we said 52%, and it never talked about mean, and it never talked about standard deviation. Okay, and our second problem, our scenario here is the ACT scores a recent school year were approximately normally distributed, so that's kind of important, with a mean of 21 and a standard deviation of 5.4. Once it starts talking about means and standard deviation, that's a means problem. If a random sample of 5 test scores is chosen, what's the probability that the sample mean is 25 or greater? Okay, so that said mean all over the place. So let's take a look. So the parameter for a mean is mu. That's your population mean. So your statistic there will be X bar. Make sure you use these notations. That's your sample mean. Now, for approximately normal, there's 3 choices here. We have to check them, and I'm going to give them to you in the order that you should check them. 1, is the population normal? That's the first thing you should check for. If you don't know the answer to that, the second thing you're going to check for is your sample size greater than or equal to 30, and that will give you normality by the central limit theorem. And if you don't have that, the third thing that you should have available for you is your sample data. Shows no strong skew or outliers. Now, if you're going to say the sample data has no strong skew or outliers and there's not a graph already made of the data, you must graph this. You must show a quick dot plot or something as part of your proof. If you were provided a graph of the data, you would say an examination of the graph of the data shows no strong skews or outliers. Okay, so our center, if we look on our formula sheet for means for the sampling distribution for one population, the mean of the sampling distribution should be the same as the population. So we have the mean of your sampling distribution should be the same as your population. For our standard deviation, the standard deviation of the sampling distribution equals the population standard deviation divided by the square root of the sample size. Okay, and so what our formula will look like for our z-score, our specific formula here, would be to find, you're going to take your x-bar minus your mu, and you're going to divide it by your sample standard deviation, which is the population standard deviation divided by the square root of n. So let's talk about it in the context of this problem. So we have the ACT scores were approximately normally distributed with a mean of 21 and a sample standard deviation, and a standard deviation of 5.4. So they're talking about overall ACT scores. So you have a mean here of 21. And then you have, let's see, a sample mean. When we go through, they wanted to know about 25 or greater. So we have an x-bar, and we're curious about the number 25. Now normal, this one's nice because it did say that the population was approximately normally distributed. So we're good on that one. We would have been okay if we didn't know about the population. We have a sample, well, we wouldn't have been good. We only have a sample of 5 test scores. So we couldn't have done the CLT because our sample size was too small. So we would have hoped for the data so we could draw a graph and see if there's any strong skew or outliers. Now, so our population, our sampling distribution mean will be the same as our population, so it will be at 21. The standard deviation of our sampling distribution will be the population standard deviation divided by the square root of the sample size, which gives us 2.41. Okay, and then we're going to plug in our z-score down below so we have a little bit more room to work. But we have all of our data now that we can kind of use for our answer. So for our picture, it says it's normally distributed with a mean of 21. So we're going to say normally distributed with a mean of 21. Now this is the sampling distribution. Or the population here, so we got the 5.4. Okay, and we were curious about 25 or greater, so we're wondering about this area right here. So our z-score, we're curious about the number 25 minus the mean divided by your sample standard deviation, which was 5.4 divided by the square root of 5, which gave us a z-score of 1.66. So for an area, we got 0.9515. Now, of course, we're asking for greater than, so you want to say 1 minus. So our area for greater than 25 was 0.0485. Right, hopefully that was helpful. Let me know if you have any questions. See you in class.